Now that we've seen a bit of radicals, we're going to make a connection between radicals and how they relate to exponents. So we're going to start by defining what those are. We're going to re-go over our exponent rules now, just more generally, and then we're going to talk about simplifying more expressions using all of these properties. Okay. So let's consider 8 to the 1/2 power. Using our exponent properties, if you take a power to a power, that just means you're going to multiply the two. So 1/2 times 2 gives us 8 to the first, which just lands us with 8. But what we've also learned is that our square and square root cancel each other out. So if I take the square root of 8 squared, it lands me right back to 8. So both of these expressions land us with exactly the same result. So it seems reasonable to say they're equal to each other. If we have the square root, we can write it as 8 to the 1/2 power. And really, this is going to be true in general. If we have the nth root of a, what we can do is write that as a fractional exponent, and you put the index in the bottom of the denominator. So let's just try some examples relating it to what we have. If I take 169 to the 1/2 power, all that means is we're taking the square root of 169. So that's the square root of 13 squared. And again, the square and square root cancel and leave us with 13. For this next one, we have 64 to the 1/3, which again just means our index is 3. So we want the cube root of 64. And 64 is the same as 4 to the 3rd power. So the cube and cube root cancel and leave us with just 4. If I try to do negative 36 to the 1/2 power, that means we're taking the square root of negative 36. And again, we can't do this. This is not a real number. At least we can't do it yet. Okay. For this next one, this means we're taking the cube root of 8 over 27. And then 8 we can write as 2 to the 3rd. 27 is 3 to the 3rd. And we're taking the cube root of that. So in the same manner as before, you can write this as 2/3 to the 3rd power. And then we're taking the cube root. So the cube and cube root cancel and leave us with 2/3. Okay. So now we know how to deal with a fractional exponent like a half, a third, a fourth, anything of that nature. But what happens if we have 3/2 as an exponent? How do we work with this? So what we're going to actually do is we're going to look at our exponent properties. So we have 16 to the 3/2. The way I can rewrite this is 3/2 is 1/2 times 3. And then when you have multiplication of exponents, remember, we can write that as a power to a power. So I would go ahead and multiply the 3.5. And now the inside I can actually work with. We can take the square root of 16 and then raise it to the 3rd power. Square root of 16 is 4. We raise that to the 3rd power. And in turn, this gives us 64. Okay? So that's one way we can actually evaluate it. What I want you to kind of notice is we're going to be able to just jump straight to this point without going through that middle property. So the index is what's going to go in the radical. And then the exponent or the numerator of that fraction is going to be the power that we raise it to. We could have also done this a slightly different way. So at this step, what we also could have done is said this is 16 to the 3rd to the 1/2. So we'd take 16 to the 3rd and then take the square root. Either one is perfectly fine, but this is definitely a more cumbersome number to go through, which is why I dealt with the radical first. But really, in general, if we have a fraction or a rational exponent, so we have an integer over an integer, you can write it as the nth root and then raise to the mth power. Or you can do the power on the inside, but still that denominator is going to indicate what the index is. All right. So let's try quite a few examples, more practice with this. We'll start with 64 to the 3/2, so slightly different than what we had before. So it's still the same exponent, but a different base. So again, we can just jump into rewriting this. The 2 is in the denominator, so that tells us we're going to take the square root. I'd again recommend putting the base on the inside, the 64, and then the 3 is in the exponent, so I'm going to go ahead and put that as the exponent on the outside. Okay. We could have instead put the 3 on the inside and not worried about that here, but doing 64 to the 3rd power would be absolutely atrocious. So that's why we'll take care of that afterwards. And now the inside we can actually do, the square root of 64 is 8, and then we raise it to the 3rd power. So if you do 8 times 8 times 8, you'll see that will be 512. So let's try this next one. We have negative 243 to the 2/5. So again, the 5 is in the bottom, so that's the index in our radical. Negative 243 is on the inside, and then the 2 is in the exponent, or in the numerator of our exponent, so that's going to be the power we raise it to afterwards. So you need a number times itself 5 times to give you 243. So if you plug that into your calculator, you'd actually see that would be negative 3 times negative 3, 5 times, will give you negative 243. And then afterwards, we raise this to the 2nd power. So that's going to give us positive 9 in the end. All right. This next one, we can take this a couple of different ways. So what I'm going to start by doing is the same thing we just did. So the 2 is in the denominator, so that's our index. And negative 3 is what we consider to be in the numerator. So we'll go ahead and put that up there. And then the square root of 81 is 9. We're raising that to the negative 3. And now here's where our other exponent rules come back into play, which is why we're going to refresh on them. When you have a negative exponent, it tells you move it into the opposite position. So it's in the numerator. We move that to the denominator to make it positive. And then 9 to the 3rd power is going to give you 729. Okay. So all the exponent rules that we did before were dealing with integer values, but honestly, the same exact things are going to hold here. Because what we could have done at this step is we could have made that a positive exponent and said this is 81 to the positive 3/2. And then from there, we can rewrite it as the square root of 81 to the 3rd, which gives us exactly the same answer because we end up with 1 over 9 to the 3rd, and you get the same thing. Okay. So all of the exponent rules that we did before, where when we multiply by the same base, we add the exponents, divide, you subtract, power to power, you multiply them, gonna hold when you have fractions or rational numbers as your exponents as well. So I just want to refresh on what all of these exponent rules are. So the exponents are going to be m and n. So these can just be rational numbers. So remember that just means a fraction like 1/2, 5/3, negative 7/9, just some kind of fraction. Okay, but it also can be whole numbers like 2, 3, 4. Those are also rational numbers as well. So let me put that in there just so it's not as confusing. This holds for numbers like 5, negative 3. All of those are rational because you can say they are divided by 1. Okay, so this works no matter what kind of exponent you have. So if we take something with the same base and we are multiplying the 2, remember we're going to add those exponents. when you have one base divided by the other base, we subtract the exponents. You have a power raised to a power, you multiply the two. If you have something to a negative exponent, you flip its location to make it positive. If the negative is in the denominator, you bring it to the numerator to make it positive. When you have two things being multiplied, raised to a power, you can go ahead and distribute it to those things. Only works when it's multiplication or when two things are being divided. So we can distribute that exponent. Really, you can also just distribute the radical. You can think of it in that way. If you have a negative exponent for a fraction, remember you can flip the inside to make it positive. Okay? Because you would have to distribute this out, and then each of them would change location because of that negative exponent. And then when you have a number divided by a number, remember again, this is going to mean you take the nth root of a to the m, or you take the nth root of a and then raise it to the nth power. Okay? So all I want to do at this point now is to just get a ton of practice trying to simplify these as far as possible. So basically getting just that single variable to a single power and writing answers with positive exponents. So this first one, we have the cube root of x times x. So to be able to apply our exponent rules, let's flip these to those rational exponents. So cube root is the same thing as 1/3 power. Square root is the same thing as 1/2 power. And now, because they have exactly the same base, we can go ahead and just add those exponents. So we want 1/3 plus 1/2. And then from here, you have to make these the same base. So this one you'd have to times by 3/3, that one by 2/2. This would be x to the 2/6 plus 3/6, which gives us x to the 5/6 as our final power. Okay. For this next one, we have the square root of x to the 20th. So we have seen examples like this, but now I can actually do this in a little bit easier of a way. So this is x to the 20th to the 1/2 power. And now we have a power to a power. We can just multiply those two. So this is x to the 20th times 1/2, or instead x to the 10th power. Okay. For this next one, we actually have a number as a base. So we have 64 to the 5/3 over 64 to the 4/3. So since they are exactly the same base, we go ahead and we subtract the exponents. So it'd be 64 to the 5/3 minus 4/3. And luckily there, we can just subtract those. You're left with 1/3. Okay, but that's something we can actually simplify. So this is saying take the cube root of 64, and you're going to get so used to these that you're going to know that that is indeed equal to 4. So this gross looking expression just simplifies to something very nice. So let's just try a couple more. We've got k to the 1/4, and then we're going to multiply it by this expression. So just like we would before, we're going to go ahead and distribute this k to the 1/4 to both pieces. So that gives us k to the 1/4 times k to the 3/2, and then minus k to the 1/4 times k to the 1/2. And since both of these have the same base, we can go ahead and add the exponents. So this would be 1/4 plus 3/2, and then for this one, it's 1/4 plus 1/2. Okay. But in order to add them, we need the same base. thankfully, we only have to multiply the second piece by 2 over 2. And same thing here. That would get multiplied by 2 over 2. So this is k to the 1/4 times, k to the 1/4 plus 6 over 4. And then on the second piece, it's 1/4 plus 2 over 4. And now we can actually add those. 1 plus 6 gives us 7 with that denominator of 4. And then 1 plus 2 gives us 3/4. Okay. And now we're going to talk about this more in the next section, but we cannot combine these because they are not exactly the same thing. So unfortunately, that one we have to leave as is. All right. So this next one, we have lots and lots and lots of z's. You can take this a couple different ways if you want. One thing you could do is you could start, because you have this negative exponent, by moving it into the numerator. You could also start by combining the two of these. Really makes no difference which route you take, you'll end up at the same place. So I'm going to go ahead and say, let's go ahead and combine these two to make it a single exponent in the bottom. So we're going to do nothing with the numerator right now. But that denominator, we can do z to the 5/4, and then it'd be plus -2. So it becomes -2. Okay. And then to save some room, -2, you can write as 8 over 4. And now when you actually subtract those two, this will be z to the 3/4 divided by z to the -3/4. Okay. And now we have the same base with division. So that means we subtract these two. So we have the numerator minus the denominator. And luckily that minus minus turns into a plus. So we have 3/4 plus 3/4, which gives us 6/4. And then that reduces to 3/2. And then we can really just leave that as is. So let's try one more super, super, super complicated one. Got a lot going on in this. So we have to do this multiplication, but we've got to take care of these exponents first. So again, you got a couple different ways, but I'm going to start with this piece. Looking at that, I do not like that both of those things are negative. So I'm going to start by flipping them. So it'd be c to the positive 5/3 over b to the positive 3/2. And then that's raised to the second power. And now here, they also are both negative, but since they're being raised to a negative power, I'm not going to worry about flipping those, because that'd be a lot of flipping that has to go on. Because instead, what we can do is we can distribute this exponent to both pieces, and it would be multiplication. So what happens is we'd have b to the -1/4 to the -1, and then c to the -1/3 to the -1. And by doing that, it's going to make it so that the negative times the negative turns into a positive. Again, not necessary to take this route, but since I've been doing this for quite a while, I tend to know stuff that just makes it a little bit easier. But if you took a different route, you'll still get to the same answer. Now we can go ahead and we can work with this one. We can again distribute this exponent because it is division, and it distributes as multiplication. So you'd have c to the 5/3 times 2. And then in the bottom, you'd have b to the 3/2 times 2. And then for these two pieces, you'd have the negative times the negative, and then the negative times the negative. So ultimately, this becomes c to the 10 over 3. And then the denominator, luckily, when you take 3/2 and times it by 2, it becomes b to the 3rd. And then for both of these, I'm going to go ahead and put these in a single fraction now. 1/4, -1/4 times -1 gives us +1/4. And then for c, we'd have positive 1/3. And now we have stuff that has the same base here, so we're going to go ahead and add those exponents. And then here we have division, so we're going to go ahead and subtract those. So this would give us c to the 10/3 plus 1/3, and then b to the 1/4 minus 3. So luckily for this first one, you can just go ahead and add those. It's 11/3. For this, we have minus 3, so writing that with the base of 4, it gives us 12/4. So subtracting those two gives us negative 11/4. And now because the directions did say to write this with positive exponents, I need to go ahead and put this in the denominator of a fraction. So this is equal to c to the 11/3 divided by b to the 11/4. So we still have quite a few more tools. Really, the next couple sections are still going to be about simplifying these, but working with other operations as well.